What comes to mind when you hear the word giant? Is it the Andromeda Galaxy, the Niagara Falls, or Mount Everest? Whatever it is you're thinking, we're going to talk about one of the solar system's largest planets. As we all know, our solar system has 4 enormous planets, the largest of which is Jupiter. Do you have any idea how large this planet is? Well, the planets Mercury, Venus, Mars, and Earth make up only 0.4% of the mass of the entire solar system, while Jupiter alone takes up 71%. This implies that Jupiter is several times the mass of any celestial object in our solar system. But this is not the aspect that we're going to discuss today. It's the fact that Jupiter is a readily available thermonuclear device floating in space with immense power, rather than just a regular lump of stone. This means this planet has the possibility of being blown to pieces. Since Jupiter is a gas giant, it is most likely made up of hydrogen and helium, exactly like our Sun, which burns because of constant thermonuclear processes. What would happen if Jupiter experienced a similar reaction? What would happen if we lit an ordinary match to the flammable gases and particles in Jupiter's atmosphere? Would the planet be destroyed by cosmic fires? Is there going to be an explosion? In today's video, we'll delve deeper into this, as well as if mankind can survive such an explosion. Are you ready? Let's get this started. About 250,000 meteors burn up per second in Jupiter's atmosphere, which is comparable to matches. The celestial matches are drawn to the planet from space and burn up in its atmosphere, but they do not ignite. Why is this? It needs oxygen to start a fire. This means that no matter how many meteors burn up in the atmosphere, fire cannot burn on this gas giant because there is no free oxygen. Try lighting a candle and covering it securely with a glass flask for a moment to better appreciate the role of oxygen in the ignition. As you'll notice, the fire will go out in a few seconds because all of the oxygen in the flask has already burned up. Although 90% of Jupiter is made up of hydrogen, it is only explosive when combined with oxygen. It's clear that an ordinary match will not ignite a thermonuclear reaction on Jupiter. Yes, fires we're used to seeing on Earth couldn't happen either on Jupiter. If Jupiter could be set on fire that easily, small meteors would have set it on fire a long time ago. However, matches in igniting a fire aren't the only highly advanced human innovation. We could use something more powerful to initiate a thermonuclear reaction. What if we used an actual nuclear weapon? Actually, we don't need to blow up Jupiter right now via a nuclear weapon to figure out what would happen in such a scenario. For almost 30 years, Jupiter has been subjected to such horrible disasters. Even the most powerful nuclear weapon would be incapable of replicating the disasters that have occurred on the planet. Astronomers recorded the first ever collision of a massive cosmic body with a planet in the solar system in 1994. This is when the comet Shoemaker-Levy 9 collided with Jupiter. This is a catastrophe that occurred on Jupiter from the 16th to the 22nd of July. This incident created major surface disturbances on the planet. As a result, the southern hemisphere of Jupiter was covered in collision traces in less than a week. The worst effect of the collision on the planet came on early July 18th, when the largest portion of the comet, with a diameter of 7,500 miles, collided with a dark patch of Jupiter. That component is approximately 450 miles smaller than the Earth's diameter. Jupiter, however, was unscathed. In this particular incident, astronomers have detected explosions of up to 6 million megatons, which is 750 times more powerful than all of humanity's nuclear weapons combined. However, the disaster's traces vanished from the massive planet's surface within a week. Or more likely, the planet has healed within a week. This isn't the only instance of cosmic bodies hitting Jupiter's surface. Another occurrence similar to this occurred in 2009, when another object, a comet, smashed with the planet. Even though the collision left a dark patch on Jupiter's surface the size of the Pacific Ocean, it wasn't enough to initiate a chain nuclear reaction. This means that even if we sent all of the nuclear bombs to Jupiter and detonated them, nothing serious would happen. Jupiter would be able to heal at its earliest convenience. There is one theory saying that it's the people that have the ability to destroy gas giants, namely Jupiter, Saturn, Uranus, and Neptune, with their own hands. You could initiate a chain thermonuclear reaction if you launched a nuclear explosion deep within the interior of the gas giants, rather than on their surfaces. This is due to metallic hydrogen, which is held in the innards of large planets under enormous pressure. If you're wondering what the future's environmentally friendly fuel will be, look no further than hydrogen planets. The transition of solid hydrogen to the typical molecular phase releases approximately 20 times more energy than when it is burned. It has the capacity to provide energy to an entire house for several years, using a relatively small quantity of metallic hydrogen fuel block. A world in which Terminators can survive for hundreds of years on their own might become a reality. Although the presence of metallic hydrogen has been hypothesized as early as the 1930s, scientists at Harvard University are only able to get it in a relatively small amount in 2016. Their achievement, however, was met with skepticism by the scientific community. Only lately have French physicists verified that solid hydrogen exists and can be manufactured on Earth. But in order to do so, a pressure of 4 million Earth's atmospheres must be created. Let's return to the topic of what would happen if Jupiter exploded. Humanity was anticipated to perish if the blast occurred. NASA opted to send the Galileo space probe into the planet's atmosphere on September 21, 2003. There were 26 pounds of radioactive plutonium-238 on board the spacecraft, yet it only takes 22 pounds of radioactive material for the ignition to occur. Unconfirmed accounts claim this brought an explosion inside Jupiter, leaving a big black spot on its surface. This was also what American writer Richard Hoagland believed in. However, NASA believes the black spot was caused by the satellite's shadow slipping into the telescope's frame, and that no proof of an explosion exists. Furthermore, Hoagland supports different conspiracy theories and frequently produces controversial writings. However, we cannot eliminate the possibility of Jupiter being blown up. To do so, however, you'd need to drop a nuclear bomb the size of the moon into its interior. Theoretically, such an explosion could result in a self-sustaining thermonuclear fusion reaction. The gas giant would be blown to bits, and the entire solar system would be destroyed on a massive scale. The explosion of Jupiter would be similar to that of a supernova, although on a lesser scale. There would be a massive emission of thermal energy and radiation into space. Furthermore, solar wind currents would be interrupted, causing most planets to shift their orbits permanently. Worst of all, the Earth that we live on would absolutely vanish. This is because the explosion will likely destroy the ozone layer, along with the rest of the atmosphere. Humans would inevitably die as a result of cosmic radiation. The effects of the explosion would be visible to the human eye for a long time in the sky. However, since humanity will come to an end, no one will be able to witness that. Despite all of this, most of us are still interested in one issue. If Jupiter had so much hydrogen, why didn't it become a star rather than a planet? This is due to the gas giant's mass being too small to undergo such a change. The hydrogen in stars is in a plasma state, which means it has been heated to extremely high temperatures by processes in their cores. This implies that for Jupiter to be a star, it has to be 80 times larger, and the temperature within the planet has to be 18 million degrees Fahrenheit. Jupiter will only be visible as another bright star in the sky if it happens to achieve these characteristics. One thing is certain though, whatever methods we try to do now, we will never be able to explode Jupiter in our lifetime. As a result, this is one reason why you should not be terrified of humanity's demise, and don't be afraid to explore space. It's preferable to wait until it's dark, grab a small telescope, and gaze at the solar system's largest planet with your own eyes. I tell you, the view will be absolutely spectacular. If you enjoyed this video, and don't forget to subscribe to the channel, please click the bell icon so you'll be notified when new videos are posted. And as always, thanks for watching Ponder This.